Hello, welcome to the video. In this lesson, we're looking at section 2.2, where we're going to look at characteristics of quadratic functions. So when we looked at quadratic functions earlier in the semester, there were certain points, there was certain definitions that we were asked to find. Depending on the type of quadratic function that we're given, whether it's standard form, vertex form, or x-intercept form, um, we had main uh, these main points that we need to look for. We were looking for like the y-intercept of the quadratic. We were looking for the axis of symmetry. We were looking for the vertex, excuse me. And then finally, we were looking for the x-intercepts if it so had any. So those were the main points that we were going for. Some of, depending on the function that we get, some of them can be relatively straightforward. We can see them. Others, we have to use formulas in order to help us out. So for this particular function, we have f of x is equal to -2 times by the quantity of x plus 3 quantity squared plus 4. We are asked to label the vertex and the axis of symmetry of this function. Well, this particular function is written in vertex form. So it is relatively straightforward to find the vertex of the function because we are looking for h comma k, because in this case this is the general function for vertex form. Would be like a times by the quantity of x minus h quantity squared plus k. So looking at this, h is -3 and k is 4. So that means that my vertex for this function is -3 comma 4. All right, now to find the axis of symmetry, the axis of symmetry is, in this case, would be a vertical line. And then this vertical line, all we have to do is look at our x-coordinate, because our axis of symmetry is always going to be attached to the vertex. So it's going to be x is equal to -3, all right? This is stuff that we looked at in that previous chapter earlier on in the semester, all right? Also, we looked at graphing a parabola in standard form. So this is the general equation for standard form. And we were able to look at that quite a bit. We were able to easily identify the y-intercept. It's whatever the value of c was, 0 comma c. That doesn't matter if a was negative or a was positive. Our axis of symmetry came from -b over 2a. Didn't matter if a was positive or if a was negative. And then if you notice, see this vertical line, that's the axis of symmetry. The vertex is always located with the axis of symmetry. So that's how I was able to find it in that previous example. And then if you look here, we got x-intercepts here and here and also here and also here. We can find that out by factoring. We can find that out by quadratic formula. You know, there's different ways that we can discover what those x-intercepts are. All right. So with that being said, what they're going to do here is they're just going to give us various functions depending on if they're standard form, vertex form, or intercept form, and they're going to ask us the various questions. So here, they're looking for the vertex and the axis of symmetry, but they give it in standard form. Still able to solve it, it's just not as easily identified like if it was in vertex form. So here they're telling us that A is 3, they're telling us that B is -6, and C is 1, okay? So in order to find the vertex, the first thing we have to do is look at the axis of symmetry. Axis of symmetry is going to be x equals -b, so it's +6 over 2 times a, which is 3. 2 times 3 is 6. 6 divided by 6 is 1. So x is 1. The vertex now, the x coordinate comes from that value of the axis of symmetry. So 1 is going to be my x coordinate of the vertex. How do we find the y coordinate? Well, we're going to take this and place it into every value of x and then solve to get my y coordinate. So to get my y coordinate, I'm going to say that this is going to be 3 times it by 1 squared, which is 1, minus 6 times it by 1 plus 1, all right? So multiplication comes first. 3 times 1 is 3, minus 6 times 1 is 6, plus 1. So 3 minus 6 is -3. -3 plus 1 is -2. So 1 comma -2 is my vertex, and x equals 1 is my axis of symmetry. Another thing that they're going to be asking you to find is your quadratic function have a minimum value or a maximum value? Whether your function is a minimum value or maximum value, the point that you're trying to find is the vertex, okay? Now, if it happens to be a minimum value, all that means is that a is a positive number because your vertex is at the lowest point on the parabola. So that's where the minimum value is. If we are looking at a maximum value, that just tells you that a is a negative number, which means that in the parabola, it is the highest number in the parabola. So you just need to find the vertex. Finding the vertex is just like what we did in the previous example. Find what the axis of symmetry is. What that axis of symmetry is going to tell us is what is our x coordinate. Then from there, we can substitute in that x value into the general equation to help us solve it, as long as it's written in standard form. So here we have a function, and it's written in standard form. F of x is equal to 1/2 x squared minus 2x minus 1. They want to know what the minimum and maximum value is. All right, so because a is a positive 1/2, we are looking at a minimum value. Okay, we're looking at a minimum value. So now what we have to do is find what that minimum value is. So a is 1/2, b is -2, c is -1. All right, I'm just looking for the axis of symmetry because it's going to be x equals -b, so it's +2 over 2 times 1/2. So 2 times 1/2 is 1, so that means my axis of symmetry is 2. So my x coordinate for my vertex, which is going to be my minimum value, is 2. To find my y coordinate, what I'm going to do is I'll substitute in x in for 2. So 2 squared is 4, so I got 1/2 times it by 4 minus 2 times it by 2 minus 1. So 1/2 times it by 4 is 2, so I got 2 minus 2 times 2, which is 4, minus 1. 2 minus 4 is -2, minus 1 is -3. All right, so what we have here is a vertex of 2 comma -3. So if I were to kind of graph that, so 2, -3, so 1, 2, 1, 2, -3, kind of looks something like this. And it's going to kind of look something close to that. All right. Here it says describe domain and range. Well, for this, domain is talking about set of x values. That means that x can be any value. So that one's going to be all real numbers. My range in this particular instance is, and since x, or since, I'm sorry, this is a minimum value, everything's going to be above whatever that value of x is. So y is going to be greater than or equal to, in this case, the value with y, I'm sorry, is -3. So everything that you put into that table is going to be either equal or larger than -3. Okay. They talk about decreasing and increasing. So basically what they're saying is it is decreasing going this way until it hits x is 2, and then it increases after that. All right, that's what that means. Here is formulas that, again, we talked about, and how to discover x-intercepts, and also the axis of symmetry and the vertex with respect to intercept form, more specifically x-intercept form. So you're able to figure out what your x-intercepts are. In this case is P and Q. And then to figure out where your axis of symmetry is, it's going to be halfway between those two x-intercepts. So it's going to be whatever P plus Q divided by 2 is. So here it asks, where are my x-intercepts? Where's the vertex? And where's the axis of symmetry? And how do we find that? All right, so to find our x-intercepts, it's relatively straightforward because it's part of the equation. So they're telling you that it is going to be -3, 0, and it's going to be +1, 0. So those are our two x-intercepts. To find the axis of symmetry, you are going to take P in this case, which is -3, add it to Q, which is 1 in this case, and divide it by 2. -3 plus 1 is -2. -2 divided by 2 is x is going to be equal to -1. So -1 is our axis of symmetry. All right. So now to find the vertex, again, same concept as before. We have -1 in for x. To find y, same idea. We're going to plug -1 into the function to see what we get as a result. So I get -2 times it by -1 plus 3 times it by -1 minus 1. So now I get -2 times it by -1 plus 3, which is 2. And over here I get -1 minus 1, which is -2. So -2 times 2 times -2 is +8. So I have my x-intercepts. Good. Check it off. -3 is 0 and 1, 0. Axis symmetry is x equals -1. And I got my vertex, so I found all three things that they're looking for. Again, these are very similar. They're both in intercept form. They're asking to find those three things. If you have additional questions, please feel free to leave me a comment, and I'm more than happy to work them out. And this is being able to look at characteristics of quadratic functions. I hope this helps. Until next time.